All right, wanted to finish up looking at the PigBus by going into some of the other sample devices that have been created and are sitting in the repository. So we already looked at the alarm clock device, and we saw some macro code that used two different timers to count up into bytes at different rates. We created a simple adder device and interacted with that through the front console. So I wanted to look at some of the more intricate devices, one of them being a server device. So there's, under the devices directory, a server.c. And this is a more sophisticated kind of device. It uses several bits in the command status register to bind to a port, wait for connections, read, write, and so on. It's a bit of a lazy server. It doesn't actually create a subprocess, so it can continue listening for connections. It only does one connection at a time, so it listens for a request. If a request comes in, it'll accept it, do the full exchange with the client, and when that connection closes out, then it will go back and listen for another connection. So I wanted to make it more general, but it was just a proof of concept. The command status register is a little more sophisticated. It's got several bits, but basically we can load a port number into the data register and then set this SPN bit to say set the port number, and that will load that port number into the device's memory, and it will open up a server socket on that port waiting for connection requests. We need to check to see if a connection has been received, so we can turn on bit 1, connection check CC, and after it has checked for a connection, it will clear this bit as usual to let us know it's processed it. When it's done that, it will also turn on bit 15, the error bit, if there's no connection available. So if we turn on CC and the device clears it and there's no error, we've got a connection. Otherwise, we know that we're still waiting for a connection to come in. Once we have a connection in place, we can turn on the read request bit, and when it's cleared, we can check bit 3, and if data available is asserted, then we have a byte coming in from the client, and we can read it from the data register. If we want to write to the client, we load a character into the data register, we turn on the write request bit, and when write request is turned off, we know that byte has been sent out. We can close the connection by asserting the close bit, and when it's cleared, we know the connection's closed. And if anything goes wrong, if we can't bind to that particular port, or if the connection closes abruptly, the error bit 15 will get turned on. So that's the basic interaction. I don't want to go through the details of the code. You can look at that yourself if you're interested, but it's the same as usual. Start device, here's our main loop, look for a command status register change, get the CSR, and then just go through and see which bits have been set. Set port number, or connection check, and so on and so forth. And that's pretty much all there is to it, right? It doesn't have to create any sub-processes because it's just using one connection at a time, so it's a pretty straightforward process. So if we go into our work directory, there's a relatively simple macro program called stest. It's test to the server code, here's the usual PigBus register definitions. Here's some flags set up to let us interact with command status register individual bit fields, stack pointer at a safe location. We load device 3, that's the server, into slot 4, or 1, but we can put it into 4. I update the LEDs on the front panel to help indicate where in this code the system is running. So 1 means that we're just starting. We're putting 1201 into the port number. We wait for that to process. If there's an error, then there's no connection. If we can't bind, we error out with a halt, and we light up this pattern on the LEDs. We wait for a connection with a 2 on the LEDs to say we're waiting for a connection. Once we get a connection, we'll just go into a loop. We'll put a 3 on the LEDs. We'll read characters from the client, display them in this lower byte, and then just for fun we'll take the value on the switches, add that to the ASCII code of the character, and send it back. So we'll get an echo to the client, but potentially, you know, adding a rotation. So simple shift cipher behavior, and then the rest of this is just reading a character and writing a character using those bits. So we can assemble that. We can run the simulation code,